The answer is there's actually rules for that. So rules for finding horizontal asymptote. And again, I'm going to abbreviate HA. So everybody's welcome to abbreviate and kind of cheat a little bit. All right. So here's what happens whenever we have, there's three situations that happen whenever I have a rational expression. I could have something where the top is bigger on top. And by bigger, I mean exponents. Exponents are bigger on top. Okay, the exponent on the top here, I've got some number, who cares what that number is out in front, x to the first, and then some number x squared, okay? And I'm looking at this, I'm going, nope, exponent's not bigger on top, exponent's bigger on bottom here. Or, so there's three cases. Exponent's bigger on top, exponent's bigger on bottom, or the exponents are the same. Okay, those are my three different cases. So we're going to look over and over again at different situations, and hopefully we'll come up with it pretty quickly what we can do here. So this one, the exponent on bottom is bigger. And what we say is when it's bigger on bottom, there's a horizontal asymptote at y equals 0. So that's my kind of first little rule that we're going to get. Okay, so for this case right here that I've got set up, this would be y equals 0. That's my horizontal asymptote. And that's what's happening with this y equals 1 over x guy that we looked at last week. There's a horizontal asymptote right here at y equals 0. And if we look at the exponents, what's the exponent on the top? Well, there's not one, right? It's just a 1. So we could say it's x to the 0 if we wanted to. But the exponent on the bottom, there's an x down there and it's x to the first. So there are more x's, so to speak, on the bottom than there are on the top. So that one has a y equals 0. Okay. The other one that we looked at last week was y equals 1 over x squared. Remember that guy? And when we graphed that one, he had two pieces also. They were both on the top because it was x squared. They were both positive pieces, right? And we found out last week that this has a vertical asymptote at y equals 0. I'm sorry, x equals 0. Got to get my variables straight. Okay, and that happened because we can't divide by 0, right? So that's my domain issue. That gives me the vertical asymptotes. That's what we did last week. This week, we're talking about this horizontal asymptote that's going on through here. Okay, and again, I see, look, the exponent on the bottom is bigger here, so it's going to automatically have y equals 0. Horizontal asymptote. Y equals 0. Okay. So that's what's going on there. We've already seen two examples of those. So I feel like, okay, that one we've got probably. All right. The other one is, what if it's bigger on the top? Well, we've actually seen stuff. Let me throw in that word exponents real fast. We've actually seen stuff already where the exponents are bigger on top. So last week we had something that looked like, I think it was something like y equals x squared minus 25 over x minus 5, something like that. I don't remember exactly what it was. Okay, but when I look at that guy, I'm looking at the top, I see a 2 for my exponent. On the bottom, I see a 1 for the exponent. This one happened to reduce out. It was actually a hole in my domain because I did have this thing going on in the denominator. So I was like, okay, there weren't any asymptotes. And if you graph that, you would see there's nothing. So this just graphs like a polynomial. Except for you'll have a hole, right? but there's no crazy asymptote going on there. So exponent bigger on bottom, there's no asymptote. Okay. And these are guys we've actually dealt with lots before. So any old polynomial will do. It's normal for us. So those two aren't so bad. And then the third one is exponents are the same. Exponents are the same. Okay, so this one ends up looking something like you've got a number with an x squared, some other stuff. Who cares what's going on in the background? We only care about the leading exponents here. And another number with an x squared. So this one is actually, I think it's kind of the quote unquote easy one to see once you learn the process, right? So the x squareds are the same. We end up with a horizontal asymptote at the number divided by the number, okay? So think of it this way. It's like these x squares will reduce out completely, okay? And so I'll end up with just this number over the number, okay? So that's my horizontal asymptote, and it'll be y equals whatever that is, okay? So I'm gonna show you the math behind why these three rules work. But so you know, you've got three possibilities. It's either there's a horizontal asymptote at y equals 0. That happens when it's bigger on bottom. There's a no horizontal asymptote. That happens when it's bigger on top. Or there is exponents are the same. So that's the horizontal asymptote where I actually get a number value. So these guys, we're going to deal with those. So what's happening? All right. When we see them, the math that goes with them, it actually ties back into the long division that I had you guys watch last week. So it looks like this. Whenever I've got 8x plus 2 divided by 4x squared minus 1, this is my y equals. When I go to do this as if it were a long division, the 8x plus 2 goes inside of the bracket and the 4x squared minus 1 goes on the outside of the bracket. That's what the long division looks like, right? And so we say, okay, hang on. What's happening here is there are more x's on the bottom. So it's like if I said, look, ignore this stuff going on the back. We don't care about that stuff. It doesn't have anything to do with the end behavior, basically. The exponents on the leading coefficient and the leading exponents, those are what deal with what's going on in the end behavior. So this other stuff makes things happen in the middle. Maybe it bounces around or whatever, but these are what has to do with what's going on long-term. So in my head, what I think is, look, there's one x on the top and two x's on the bottom. One of those would go away with one of those, right? So this is about the same as saying 8 over 4x. And then when I think about that, I'm going to deal with, okay, but what is this? If I go way out into the long term, this is like an infinity on the bottom. This is going to go towards 0, okay? So if you're not sure what I mean by that, it's like test different points. So what if it was 8 over 4 times 1? Well, that's just a 2, right? But if it was 8 over 4 times 10, that's 8 over 40, that's like 1/5, okay? So this is getting closer to 0 already. But what if it was like 8 over 4 times 100? Okay, well, that's like 1 over 50, right? Okay, so you just keep on looking at it, and this is really, really, really small, right? This is really closer to 0. So eventually what's going on is it's getting close to 0. Okay, and like I said earlier, that's like a limit in calculus. Okay, when I do this long division here, I look at it and I say, can I put the x squared into the x? And the answer is no, I can't, because there aren't enough x's to go in, right? I need at least an x squared for this x squared to divide into, but it won't. So it's a 0 up there, okay? And I'm going to have some remainder stuff, but there's nothing I can do with it. So I can't really divide this. Y equals 0, okay? So no matter which way you're thinking about it, you can look at it 2 or 3 different ways. You can just memorize the rule, whichever one you want. But no matter which way you're looking at it, I'm always getting close to 0 here. Now, a real quick, by the way, about horizontal isotopes. I said the other day, you can never cross a vertical isotope, right? Because that's a bad spot in the domain. So it just can't happen. Okay. But these guys, these horizontal isotopes, they're not about bad spots in the domain, right? They're just kind of about in behavior. Horizontal isotope are about in behavior. What's going on as we get out closer to infinity or closer to negative infinity? X equals 300, 500, a million. Okay. So in the end, at the ends, we're not going to cross. Okay. But in the middle of the graph, it might. So I don't know if you noticed or not, but the other day we had a graph, and it was probably just on the calculator, so I probably don't have it. And it looked something like this. We were working with it. It came up and then it went like that. Okay. And then from the other piece, I think it looked like that. So there was like a vertical isotope. We were just dealing with vertical isotopes, so I didn't mess with the horizontal. But there is a horizontal isotope here. It's at the y equals 0 guy. And what we saw was it bounced or it crossed through it and then it came down. And the reason why is toward the end way out here, we're getting closer and closer and closer to the horizontal isotope, which is the y equals 0. Okay. So that's what's going on there. And this one didn't ever cross it. But these, think magnets. Drawing it really close. So even if it crosses it in the middle, right in the middle of the graph, it's still going to pull back down and get really close to that isotope. All right. All right. Let's see this one. 8x cubed minus x plus 2 divided by 4x squared minus 1. This was my f of x. Okay. If I use the horizontal isotope rule, then what it tells me is we don't care about any of this stuff back here. We're just looking at this leading guy right here. Look at those exponents. The exponent on the top is a 3. The exponent on the bottom is a 2. So this is bigger on top. Exponent's bigger on top. Okay, and that rule was what? There's no horizontal isotope, right? That was that rule. Okay. And if you want to know the mathematics behind that guy, what's happening is if we were doing this as a division problem, and I'm just leaving the other stuff off because that other stuff just doesn't matter. It doesn't have anything to do with end behavior. Uh-oh. Somebody lost their connection. I'm sorry. So, but if what's happening here is when I go to do this, I say, hey, when I divide this in, this will actually go. Oh, I'm sorry, that was 3 there. 8x cubed on top divided by 4x squared, right? Okay, this will actually go in. X squared goes into x times, right? So x times x squared would give me the x cubed. And 4 goes into 8 2 times. 2 times 4 is the 8. So this will go, that's good. And I look at it and I say, but this isn't an isotope. right? Okay. It's not a horizontal asymptote, I should say. Okay, it's not an asymptote. This is just, we're just graphing it, right? So when you look at this one, it doesn't have a horizontal asymptote. We actually end up with something, oops, sorry, no horizontal asymptote. We actually end up with something that's called a slant. So that's where we're gonna head if we have enough time at the end. If not, we just realize, hey, occasionally we don't get a vertical or we don't get a horizontal asymptote. Instead, we get a slant. Okay, but there's no horizontal asymptote here. And if it was bigger than, notice that this exponent's only one bigger than the bottom. Okay, so that happens only when slant, I'm gonna just throw it in here. Slant asymptotes only happen when we're exactly one bigger. Of course, I don't have room. Exactly one bigger on top. So in other words, if that had been x to the fourth divided by x squared, and we went to go do this, we wouldn't have a line going on here at all. This is y equals 2x, right? We can graph that line. It's pretty easy. It just looks like that, right? Rise over run, goes through 0, 0, all that kind of stuff. So that is not a terrible thing, but it only happens when the top is exactly one bigger. All right, I want to show the third case. So the third case looks something like this. Let's do 8x squared. Half of x equals 8x squared minus x plus 2 all over the 4x squared minus 1. Same guy. I keep on dividing by the same guy here. It's because I don't care what the other stuff is at the back side of it. All I care about is the front guys, what's going on there. So again, we'll ignore all this stuff back here. We'll focus in on these leading terms. And we say, hey, look at that. Those have the same exponents. Okay. So this is the case where the exponents are the same. Okay. And then I say, okay, what does that mean for us? This is our third case. There must be a horizontal asymptote at y equals, get rid of that x squared, get rid of that x squared. It's just whatever numbers are sitting out there, right? 8 divided by 4 is 2. Okay. So that's it. You just look at it, you go, hey, look, those have the same exact x exponents. And so those will basically reduce out, and all I'm left with is the coefficients. So that's why I said, mathematically speaking, this one's not terrible. It's probably the easiest of the three to kind of look at and go, oh, 8 over 4. You just have to get used to looking and saying, I'm going to ignore everything in the back. I'm going to look at the exponents. They're the same. So I'm going to ignore those. And now I'm going to say, what are the coefficients? 8 over 4. All right. Okay, so that's what we're looking at. I think the one that we were doing the other day, let me find one. We're going to graph one from start to finish, and we're going to see what's going on with it. So, because we got to put all this stuff together, right? So here I've got an example. Yay, examples. And the example says, graph this guy. It is g of x equals 3x squared minus 3x all over x squared plus x minus 12. Okay. So when we go to graph these things, it's going to look a lot like the stuff we've done in the past. I will say that the things you need to remember, okay, of course, we've got these asymptotes. We're going to have to figure those out. So we're going to keep up with asymptotes. But then if we want to still graph the rest of the thing, the old stuff that we are used to is going to come into play. So we've got intercepts going on, x-intercepts, y-intercepts, that stuff's still going to be there. Okay, and hopefully it tells me something about my graph. the end behavior of the graph. So hopefully we know a little bit about if it's positive, it's negative, which way is it hitting and all that kind of stuff. And if we need to, we'll graph some extra points. But this is a sketch, okay? So we're gonna do our best without going crazy about, graphing every single little bit of the graph. So we're getting a sketch, okay? All right, so hopefully you're already working on it. Asymptotes. What about vertical asymptotes for this one? Remember how you do vertical asymptotes? Take the denominator, take that guy out, x squared plus x minus 12, and set it not equal to 0. It cannot equal 0. That's how I know the bad spots. These are always, for the verticals, bad spots in my domain. All right, now I'm looking at this and I say, I hope this guy factors, and it will. So x and x for the first two guys. And I see it multiplies together to give me negative 12. So one of them is a positive and one of them is a negative to give me this negative 12, plus and minus. And then I know that they're factors of 12 that add up to be a positive 1 in the middle. So like it could be 1 and 12, but those are too far apart. 2 and 6, no. But 4 and 3, those are only 1 apart, right? So if I use a positive 4, and a negative 3, check that and see if this will come out right. So x squared minus 3x plus 4x. Yep, that's going to give me the 1x in the middle and minus 12 at the back. So hopefully our factoring is really good by now because we've been doing it for a while, right? X plus 4 can't equal 0, or x minus 3 can't equal 0. This guy, subtract the 4, x can't be negative 4. This guy, add the 3. X can't be 3. So I've got 2 spots there that I'm going to have to watch out for, right? Oh, let me move that up a little bit. All right. Now, what I want to make sure of for those is I want to make sure they won't delete out or reduce, right? So I'm going to go ahead and look at the top here. It was, let me rewrite it because I'm on a different page. 3x squared minus 3x, right? And I'm going to write the bottom as x plus 4, x minus 3, now that we got it factored. Okay, so I'm looking at this guy and I'm going, look, there's a 3x in here that'll factor out. Does everybody see that's in common? I can just factor the top. 3x. When I factor out a 3x out of this first term, I'm going to be left with 1x. So that'll give me the 3x squared whenever I multiply it through. And when I factor out 3x out of this last term, I'm left with a minus 1, right? So double check, 3x squared minus 3x. Yep, that's right. Okay, so the top does factor, but now I'm looking at it and going, hey, do I have anything that'll reduce? And the answer is no. So I was a little bit worried we might have an x minus 3 up here on the top, but then I saw that the 3 is going to factor out, right? So there's not an x minus 3. There's no removable discontinuities. So that means both of these are vertical asymptotes. Vertical asymptotes at x equals negative 4, x equals 3. All right, so we're going to get that guy in there in a second. Both of those are vertical asymptotes. Nothing was removable. All right, and so now I need to use my little rules about horizontal asymptotes. Okay, so I'm going back to the original. Here it is. I don't care about the stuff in the back. I care about my leading terms. 3x squared over x squared is what I've got. So I'm going to cover that stuff up. And I look at that and I go, hey, they have the same exponent, right? So when I see they have the same exponent, that means those will reduce out too. And all I'm going to be left with is a horizontal asymptote at what? Y equals 3, right? It's really 3 over 1. because there's technically a 1 sitting right in front of that x squared. But we don't care about that one, so we're just going to say y equals 3. Is that all right? Y equals 3. Okay, the horizontal asymptote at y equals 3. Okay, so that gives me my isotopes. And then I want to know about intercepts. So let me go ahead and start sketching this guy a little bit. I'm going to put on a grid. We said there's a vertical asymptote at x equals -4. I'm going to put that dashed line so we know it's there. That's a vertical asymptote. We're not going to cross it. And there's a vertical asymptote at x equals 3. That's on the positive side. Okay. And there's a horizontal asymptote at y equals 3. Okay. So when I get to graphing these, I kind of think of these asymptotes as this is what's splitting up my graph, right? I know I've got 2 verticals, so I'm going to end up with 3 pieces of the graph, right? One's going to be on the left, one's going to be in the middle, one's going to be on the right-hand side. So those vertical asymptotes tell me I got to have 3 pieces of a graph, okay? I don't know if they're above the y asymptote or below that horizontal asymptote, but I know that they're in there somewhere, okay? So let me get my intercepts because those are going to be important points that are going to help me kind of figure out what's going on here. All right. So in order for me to get a x-intercept, I make y equals 0, right? So my original guy was 3x squared minus 3x. Well, not quite original. I'm going to use the x plus 4. X minus 3 guy on the bottom. Okay. But it doesn't matter about the bottom because whenever I go to solve this guy for x, I'm going to have to clear the denominator, right? Multiply both sides by this x plus 4, x minus 3. So that it clears out on the bottom. And when I multiply all that stuff by 0, what happens? Anything that we multiply by 0 is just 0, right? So all of that goes away. So that's the nice part. All that denominator stuff goes away. And I'm just solving for 3x squared minus 3x equals 0, okay? And since we already factored that, let's do that again. 0 equals 3x times x minus 1. And this guy just becomes a quadratic equation that I'm trying to solve, right? So I've already got it factored. I'm just going to set each of those equal to 0. 3x equals 0 or x minus 1 equals 0. Kind of running into my graph here. Dang it. Okay, so either way, divide by 3 here, x equals 0. Add 1 there, x equals 1. Those are my x-intercepts, and those are going to tell me so much about this whole entire graph. So I know I've got a point right here, x equals 0, and I've got a point right here, x equals 1. Okay, so here's what I'm betting is going to happen here, okay? Because these are asymptotes and they're pulling my stuff toward me, toward these like magnets, I'm betting that this looks like a parabola in the middle. And they're going to come down here and get really, really, really close on that. The other thing I know is there aren't any more x-intercepts, right? So there can't be an x-intercept over here on this left-hand side piece. And there can't be an x-intercept on the right-hand side piece, okay? So because there aren't x-intercepts here and here, and I have these asymptotes, think about fitting your graph into those asymptotes. They're just going to kind of suck it up against them, okay? So those have to be on top of the horizontal asymptote because I don't have any x-intercepts on those sides, right? The only x-intercepts are right here in the middle. So the question is, does this come up and go up against it? Or does it come up and bounce somehow and then go back up? It could cross the horizontal asymptote here in the middle, okay? So what I want to do is plug in maybe one more point and find out what's going on. So when I put in, let's just plug in negative, let's say -2 right here. Okay, so I'm going to plug in -2 into this whole thing. And I'm going to say -2 squared is 4. 4 times 3 is 12 minus, and then it was 3 times -2. That guy's going to be 18 on the top. So I'm just saying x equals -2, y equals, it's going to be 18 on the top, and then -2, oops, +4 on the bottom is a 2, and -2 minus 3 on bottom is a -5. Oops, let me scoot. So I don't really care what this number is. Again, I've got y equals 18 over -10. I don't care exactly where that is. What I care about is this is a negative number. Okay, so I've got 2 and then whatever -18 that's almost 2, right? It's down here somewhere. So guess what's going on there? And there's no other x-asymptotes or x-intercepts. That guy must be pulling down, right? And it's going to get really close to this asymptote over here. Okay, it's got to come up and it's got to come down right there. So maybe we need to plug in 2. Well, if it was 2 squared, it'd be 4 times 3 is 12 minus 3 times 2 is 6. That's 12 minus 6. That's 6. That's fine. It's positive. Let me do it right here. Y equals 6 on top. And then 2 plus 4 is 6. 2 minus 3 is -1. Again, I've got a negative answer right there because it's a positive over a negative. I don't really care about the answer, although it is a -1. It's not horrible. What I care about is it's pulling it down. Okay, so we're going to check this on the calculator real fast. I know I'm running low on time. So let me check it on the calculator real fast. So the top is going to be, I'm going to use parentheses, 3x squared minus 3x divide by the bottom in parentheses is, let me go back to the original, x squared minus or plus x minus 12. Okay, there's that bottom. So graph that sucker and see. Look at that. Perfect. It's just exactly what we thought it was going to be. Okay. And I know their graph is prettier than my graph, but that is what it should look like. And that is awesome. Okay. So we're just using all the stuff we already know, plus our little horizontal asymptote rules. Is that your bell? Not quite. Okay. So hopefully all this makes sense. And you just stick it all together. I've got other examples if you want to see some of them or do some of them on your own, or just start playing in the homework and see how that looks. So are we okay? All right, your bell's about to ring, I know. So if you don't have questions, go ahead and pack up. Yay. See you later.
Can I see the paragraph that you wrote on the last page, the previous page?
The what?
It was like a little mini paragraph. I think it was like 2 pages back for you. I didn't get to finish writing it down.
Here.
Yes, thank you.
You're welcome.